Okay, so here, I think this might have been the last slide we were up to. If you remember, last time, what we did was we, saw what lines and what the slope of a line is, okay? That's what the M here represents. The formula for slope was given last time, right? It's basically change in y over the corresponding change in x. I know it was also written as y sub 2 minus y sub 1 over x sub 2 minus x sub 1. You can use that way as well. It's the same thing. I wrote rise over run. I know some people know the slope that way. That's fine. It's basically up to you. I was going to say, oh, okay. So this I just wanted to point out again. The slope of a line, is also called a rate of change. The idea there is if you're on a line, let's say, right? If you were to increase your x by 1 unit, okay, again, x is your independent variable. If you increase that by 1 unit, your output will change by m units, okay? Your output will change by m units. It's going to increase by m units, okay? That's what's going to happen here. So if you increase it by 1, your y value will change by m units. M's the slope. It might increase if m is positive. It'll decrease, of course, if m is negative. And if m is 0, it won't change at all. You could think of it almost like the speed of a car. When you're driving a car, right? You're driving, say, I don't know, 10 miles an hour. Well, I guess speed in general, but let's say 10 miles an hour, right? At that speed, if you were to drive another hour, so you increase time by 1 hour, your distance, that's going to increase by 10 miles. It's the same idea. If you go on into calculus, they go a lot more into rate of change. But again, I'm not going to go more into that here. It's just something I felt better. I felt better pointing it out. So, all right. So that's rate of change. So let's do some examples with slope. So let's say let's find the slope of the line passing through these points. Let's do that. And this pair as well. So again, what do you want to do? You want to do the change in y divided by the corresponding change in x. So what I did here was I did -2, right, minus -4. So I'm going from the second point to the first point, divided by 5 minus 1. Okay. So again, we have here, let me get the laser thing again. We have change in y, -2 minus -4. Okay. And divided by the corresponding change in x, right? We did from the second point to the first point. Same thing for the x coordinate, 5 over 5 minus 1. So what do we get here? We get -2 plus 4 divided by 5 minus 1. -2 plus 4 divided by 5 minus 1. And of course, doing so, we get 2 over 4, which is a half. Okay. Okay, let's do the next one. It's the same idea, right? So we have change in y, so we can go from the second point to the first point, 3 minus 0, divided by 0 minus 3, right? Change in change in y over corresponding change in x, right? So we have 3 minus 0 over 0 minus 3. And here we get 3 over minus 3, which of course is minus 1. Okay. You can actually tell ahead of time before the calculations if your slope is going to be positive or not. And how is that? Well, notice from the first pair here, right? If I go from this point to this point, namely from the x coordinate to the larger one, right? So here the x coordinate is 1. This is 5, the larger x coordinate, right? The y coordinate, the corresponding change there, is increasing as well, from -4 to -2. From -4 to -2. So again, we're going from 1. So if we go from this point to this point, the x coordinate is increasing. The y coordinate also increases. That tells you the slope has to be positive, which is what we got. From here, with the second pair, again, if we go from this point now to this point where the x coordinate is increasing, 0 to 3, what's the y coordinate doing? It's decreasing from 3 to 0. So from here, if we increase the x coordinate, the y coordinate goes down. That's how we know the slope has to be negative, which is what we got. I mean, I really hope that made sense. I think it'll make more sense later when we see some examples, more examples, that is. I'm just trying to help you see that ahead of time, if the slope should be positive or negative. I mean, what's unfortunate about slope is you're subtracting, and if you subtract, you can't subtract in any order you want. Okay. What questions do you have about this? Okay. Well, let's keep going then. Here's one with a graph. So let's find the slope of this line. Now remember, to find the slope, you can use any 2 points you want. I have 2 points labeled here, 3, 4, and -3, -1, okay? We could really use any other points we want. I just chose those 2 points, okay? But you could probably use this point here, which looks like it is 0, 1.5. But anyway, for these 2 points, which are labeled, right? Okay, so again, what do we do? Let me get the wonderful pen out. I can find it. Here we go. Okay. So again, what do we do? Change in y. 4 minus -1, right? That's on top. Divided by 3 minus -3. Right? Change in y, the difference that is, divided by the corresponding difference in x. Okay, good. All right, that's good. So what do we get here? We have 4 minus -1 over 3 minus -3, which is 5 over 6. And that's our slope. And again, you actually could tell ahead of time if the slope is positive, or if the slope is positive or negative before you do this calculation. The next slide will make it more clear. Mostly because we have the graph actually. Are there any questions about this? let's keep going then. All right, so here, what we're going to do now is we're going to do some more calculations. We're going to compare them. So, excuse me. So let me get the laser thing out. There we go. So for the green line, right, that's this line here. That line is passing through the point 1, 2, which is down here, and the point 2, 4. Okay. So what is the slope of that line? Well, we have 2 points on the line, right? I mean, you probably could get more, but for the 2 points on the line, 1, 2, and 2, 4, what would the slope be? Well, we have 4 minus 2, right? Again, change in y, divided by corresponding, wait, let me fix that. Didn't mean to go up, meant to go down. Let me just fix that, I want to be consistent. There we go, there we go. All right, change in y over the corresponding change in x, right? In the same order, so to say. From this case, from the second point to the first point. 4 minus 2 over 2 minus 1, which is 2. So that slope is positive. Okay, that's good, that's good. Now let's do the same thing with the other line, with the blue line. That's this line here. This line, as you can see, is passing through points 1, 2, just like the green line. It's also passing through 2, 6.